We are going to draw a tree diagram. You get to choose from a hamburger or a hot dog or a brat. And then you get to pick from one of the either chips, slaw, or beans. Okay? So let's say we choose a hamburger. We could get a hamburger with chips. We can get a hamburger with slaw. Or we can get a hamburger with beans. Well, if I don't want a hamburger, I can get a hot dog, but with a hot dog I can get chips. I could get a hot dog with slaw, or I could pick a hot dog with beans. But I don't want that either. I want to get the brat. I can either get the brat with chips, a brat with slaw, or a brat with beans. Sometimes you get to pick a drink that goes with that, so you would branch it off on each one of these. Okay, so well, we're going to make our sample space. We have to create a sample space. That's what they're going to have you do. So you have to write a hamburger with chips. You got to write hamburger with slaw. Or I can get a hamburger with beans. How many meals was that? Just with a hamburger? 3. Another part of the sample space. You can get a hot dog with chips, a hot dog with slaw, or a hot dog with beans. But I can also get a brat with chips, a brat with slaw, or a brat with beans. Those are the different combinations of meals that I can get. So how many total outcomes are there? How many total outcomes do we have? Maria?
9.
You have 9 outcomes. There are 9 different meals. It's kind of like saying if I have 4 shirts, 3 pair of pants, and 2 pair of shoes, how many different outfits can I create from that? Well, you would have to make a branch for the 4 different shirts, then match them up with the 2 different pants, and then match each one of those up with your shoes. It was 3 pants and 2 shoes. Well, notice that we have 3 options for the main dish, right? How many did we have for the sides? 3. How do you think you can get 9 outcomes? How do you think you can get 9 outcomes without drawing the tree diagram? Jackson? 3 times 3, and that's what the fundamental counting principle says. It says to find the number of ways 2 or more events occur, you take m times n. Okay, so if I have a debit card and I have to put my PIN number in, right? How many numbers are in the PIN? Gavin? 4. Every time I do this, I make 4 blanks. 4 blanks. Okay? How many numbers do you have to choose from for the first number? How many numbers do you have to choose from for the first number? How many? What do you think? Addie? 9? Digits to choose from for the first number in my PIN. How many do I have for the second one? No, Because if we can use them repeatedly, there's still 10. How many do we have to choose from for the third one, Piper?
10.
And then the last one, Christian?
10.
So how many outcomes would there be for my PIN number, Jackson? 10,000. Okay? Let's talk. We're going to talk Powerball. Okay? I think there's 6 digits that are pulled, right?
Yeah.
So I'm going to make 6 blanks. Okay? So let's say the Powerball has 68 balls that are in the thing that go around, then they suck them out, right? And they put them in line. How many numbers do they have to choose from for the first ball? Jackson? They take one out, don't they? Jackson, how many do we have for the second one? What about the third one? The fourth one? Fifth one? And the 6th one. Multiply those together on your Desmos scientific calculator. Say. 10 to the what power?
10.
How many of you got that? That's in scientific notation, isn't it? So what is that in standard form? What is that in standard form? Remember this? What would I do here, Kobe?
You move the decimal between 7 and 8 and times to the right.
Yep. So there's 1, right? I need 9 more zeros. Correct? And put your commas in there. So you have 1 out of 78 billion chances of winning. Like I said, the chance of you picking the Powerball, it's better to get struck by lightning. Okay? So if they said you have a combination, let's say your laptop has a 6 numbers or digits, okay? And it's 2 letters followed by 4 numbers. Okay, and these letters, they can be upper or lower case. We certainly don't want to do a tree diagram for this, do we? Nor do we want to do a tree diagram for the Powerball or Mega Millions. So how many choices do you have for the first letter? How many choices do you have for the first letter, Seth? 52. Let's say it can't be repeated. So how many would we have for the second one? How many would we have for the second letter? Jacob? 51. Followed by 4 numbers. How many numbers do we have to choose from? 10. Let's say it can't be repeated. So how many numbers would we have to choose from for the next one, Camden?
9.
And then the next one, Camden?
8.
And then the last one?
7.
How many different passwords could you put on your computer?